YR4 is a brand new asteroid that we discovered on December 27th, and it currently ranks first on the list of asteroids with the highest risk of colliding with Earth. Calculations indicate that if a collision were to occur, it would happen on Wednesday, December 22nd. That means we only have 7 years. But how is this possible? How did we overlook such a dangerous object? Could it wipe out life on Earth? Or is this all just media exaggeration? Let's find out. The inner solar system and its surroundings are filled with asteroids. It's impossible to know the exact number, but generally, we know that larger asteroids are less common, while smaller ones are far more numerous. Still, the numbers are alarming. For example, it is estimated that within the asteroid belt, between Mars and Jupiter alone, there are about 1.5 million asteroids larger than 1 kilometer in diameter. I can't even include asteroids smaller than 1 kilometer because we lack the technology to determine their exact number. Estimates suggest that there are millions, possibly tens of millions, of tiny asteroids in that region. For comparison, consider this. The asteroid that struck Earth around 66 million years ago, wiping out all dinosaurs except for birds and most species living at the time, was about 10 kilometers in diameter. So, the fact that there are 1.5 million asteroids larger than 1 kilometer in a region that could be considered our cosmic backyard is truly frightening. Moreover, about 200 of them are over 100 kilometers in diameter. To put it in perspective, the largest asteroids to ever hit Earth likely did so in its early formation, billions of years ago. Back then, the solar system was much more chaotic. In fact, aside from asteroids, we know that a protoplanet the size of Mars, known as Theia, collided with Earth, ejecting debris into orbit that eventually formed the Moon. However, since Earth's surface was much more molten and covered in lava at that time, most traces of these massive impacts have been erased. The most enduring evidence of the largest collisions dates back billions of years and can be found in the Barberton Greenstone Belt in South Africa. Ancient marks in this region indicate that the craters formed back then reached up to 1,000 kilometers in diameter, and the asteroids that created them were likely tens of kilometers across. These were impacts powerful enough to wipe out all complex life in an instant if animals and plants had existed at the time instead of just bacteria and archaea. And just beyond Mars, there are hundreds of asteroids more than twice the size of those impactors. Just to put things into perspective, but aside from these massive cosmic giants, as I mentioned earlier, and as this graph illustrates, the larger an asteroid is, the rarer it is in space, making its chance of colliding with Earth significantly lower. For example, moving from smaller to larger, dozens of asteroids smaller than 1 meter in diameter enter Earth's atmosphere every day. Of course, while these smaller asteroids may be tiny in size, their vast numbers mean their total mass can exceed 100 tons per day. That's no small amount. Fortunately, most of them burn up in the upper layers of the atmosphere, converting into heat and leaving behind only the beautiful visual spectacle we call meteors. Asteroids ranging from a few meters to a few dozen meters in diameter still fall to Earth periodically, depending on their size. Almost none of these reach the surface, but they burn up much more brightly in the atmosphere. The real danger begins with larger asteroids. At that point, they can either reach the surface, or even if they don't, the shock waves they generate in the atmosphere can cause significant damage on the ground. For example, the asteroid that fell over the Chelyabinsk region in Russia was of this size. If you recall, the shockwaves from the explosion shattered thousands of windows and injured hundreds of people. Even larger asteroids are almost certain to reach the surface. These impact Earth at certain intervals, causing major local destruction, such as the Tunguska event. If they hit the ocean, they can trigger tsunamis, adding another layer of devastation. The asteroids that NASA considers true threats are even larger. These strike Earth at predictable intervals, causing severe destruction in their impact zones. If one were to hit a densely populated city like Istanbul, it could result in the collapse of hundreds of buildings and thousands of deaths. Asteroids of even greater size can cause global-scale disasters. This doesn't necessarily mean mass extinction, but they can still trigger sudden climate shifts, massive tsunamis, years-long wildfires, and even block out the sun for weeks due to the dust they kick up. Finally, the largest asteroids don't just cause global devastation. They can lead to the extinction of multiple species, or in extreme cases, nearly all life on Earth. Fortunately, these events occur over incredibly long periods. Of course, all of these numbers and predictions are based on statistics. After all, a 10-kilometer wide asteroid isn't floating through space thinking, "Now's the perfect time to crash into Earth." Using data gathered from both astronomical observation tools and geological records, we statistically estimate how frequently major impacts have occurred on Earth. This is where our impact probability calculations come from. In theory, there is no fundamental barrier preventing two massive asteroids from colliding with Earth within a short period. However, because such enormous asteroids are relatively rare in space, their chances of impact remain relatively low. Ultimately, asteroids in the solar system have had billions of years to either settle into stable orbits, collide with a planet, or fall into the sun and be destroyed. Most of them have already followed one of these paths. Think of it this way: the same uncertainty applies to the damage an asteroid could cause on Earth. Of course, the consequences of a 50-kilometer wide asteroid impact are almost certain. But for smaller asteroids with a potential collision course, the level of destruction depends heavily on factors such as the angle of impact and the asteroid's speed. The exact same asteroid could cause an absurd level of destruction if it collides head-on with Earth at an immense speed and a steep angle. However, if it approaches Earth in the same direction as its orbital movement at a relatively lower speed and at a grazing angle, it might not even reach the surface. This is because the steeper the angle of entry, the longer the asteroid has to travel through the atmosphere, giving it more time to burn up. To quantify all these different risk probabilities into a single number, experts use a scale called the Torino scale. In this unusual chart, the vertical axis represents the kinetic energy released by an asteroid upon impact, regardless of its speed or angle. The horizontal axis, on the other hand, represents the calculated probability of impact for each individual asteroid. As you might expect, the higher the probability of an asteroid hitting Earth, and the greater the kinetic energy it is expected to release, the higher its score on the Torino scale. These high-risk scenarios are shown in the upper right corner in orange and red colors. Conversely, the lower the impact probability and released energy, the lower its ranking on the scale. As you can see, most of the scale is occupied by values ranging from 0 to 4, because asteroids capable of releasing massive amounts of energy have a relatively low probability of colliding with Earth. Now, with all this information in mind, what do we actually know about the newly discovered asteroid YR4? Let's get into it. YR4 is estimated to have a diameter between 40 and 90 meters, and its probability of colliding with Earth is calculated to be between 1.6% and 2.2%. The lack of precise numbers might surprise you, but this is actually the key takeaway from this video. Look, this is how an asteroid appears in our telescopes, or if I stabilize the background, it looks like this. Now, try to calculate its size and trajectory. The footage I'm showing is compiled from observations spread over several days and weeks. We only recently discovered this asteroid, meaning it has only been a short time since its detection. What does this imply? It means we only know a small segment of this asteroid's orbit. Of course, using orbital mechanics and knowing that this asteroid orbits the Sun, we can estimate its full trajectory based on this limited data. For example, we estimate that YR4 completes one full orbit around the Sun in approximately 3.99 Earth years and has an orbital inclination of 3.41 degrees. However, these are just predictions, and the margin of error is still not close enough to zero. In most cases, we need to observe a new celestial body for at least one full orbit around the Sun to accurately determine how various forces influence its motion. This involves a probabilistic approach. Based on observations made a few days apart, we try to predict where the asteroid will be the next day. A day passes, and we check, was our prediction correct? It's mostly accurate, but there's a small deviation. With this new data, we update our calculations and make a prediction for the next day. In reality, these calculations are not just for a single day, but are extended far into the future, predicting the asteroid's position for years to come. But to simplify, we continuously compare predictions with real observations, refining our calculations and reducing the margin of error over time. However, that margin is still not close enough to zero. While we can accurately model how large celestial bodies, like the Sun and planets, influence YR4's trajectory, we cannot precisely determine how it is affected by smaller nearby objects of similar size due to gravitational interactions. Moreover, for small objects like asteroids, even subtle factors, such as which side faces the Sun at different points in their orbit, can influence the amount of gas and dust ejected from their surface, leading to slight orbital shifts. Over months and years, these tiny changes accumulate, resulting in uncertainties that are difficult to predict with absolute precision. This is why we can only calculate probabilistically whether YR4's trajectory will intersect with Earth's orbit and on which exact day this might happen. Current calculations indicate that YR4 and Earth's paths may coincide on Wednesday, December 22nd, 2032, at a 2.2% probability. Take a look at this graph representation. Each yellow dot represents a possible trajectory YR4 could take on December 22nd, 2032. Notice how only a small fraction of these dots overlap with Earth's position at that time. That small overlap corresponds to the 2.2% probability of impact. However, let me emphasize that updated calculations over time may increase or decrease this percentage. Similarly, the size of the asteroid will become more accurately known as different telescopes observe it from various angles and conduct precise measurements. The tricky part is that while we say we just discovered this asteroid, there will actually be a period from April to June this year when it won't be visible to ground-based optical telescopes. During this time, only infrared telescopes will be able to detect and track its trajectory. Regardless, by the time I publish this video and you watch it, the numbers I mentioned might have already changed. To better assess the risk, let's take a look at the Torino scale. YR4 falls somewhere between 0.01 and 0.99 on the Torino scale, which corresponds to this region here. If its size is between 40 and 90 meters, it would be placed around this vertical range. This number indicates that while the asteroid or comet will pass relatively close to us, the risk of impact is not significantly high. Additionally, calculations, though with a higher margin of error, suggest that the most likely impact locations lie along this red trajectory line. So, there's no need to rush your bucket list just yet. Our Colombian or Indian viewers might have more reason to worry. Just kidding. But in all seriousness, if the worst case scenario happens, and YR4 actually collides with Earth in 2032, it is unlikely to pose a threat to humanity or life on a global scale. However, if it happens to strike a major city, it could cause catastrophic destruction, potentially wiping it off the map. This highlights the critical need for increased investment in space research, not less. We already know how to protect ourselves from such asteroids, and with enough resources allocated to the cause, we could greatly extend our species' survival. As for how we could defend against asteroids, like the one that wiped out the dinosaurs, we will cover that in detail in another video. If you don't want to miss it, make sure to turn on channel notifications now. So, that's the story. YR4 is an asteroid significant enough to deserve humanity's attention, but not alarming enough to cause mass panic. Based on what we know so far, it could lead to a terrifying, yet smaller scale disaster, similar to the Chelyabinsk event. If it were to strike Earth, it could carve out a 1-kilometer wide crater, much like the famous Barringer crater in Arizona. The impact could erase everything in its immediate vicinity: people, animals, plants, and even entire cities. But to determine the full extent of its potential destruction, we need more observations in the coming months and years to better understand its mass, composition, and trajectory. If any critical discoveries are made, I'll be sure to keep you updated. If you enjoyed this video, don't forget to like. See you in the next video. Take care.